Welcome to this session. We have two problems for us to solve. So the first one is the integral of ln of x, and the second one is the integral of sine inverse of x. So let's discuss the solution. So solution, integral of ln of x dx. So one thing that we observe is that this can be written as ln of x times 1 dx. So therefore, we use integration by parts formula to get the solution. So we let u to be ln of x and dv to be this 1 dx. So du, differentiating ln, we get 1 over x dx, and v will be the integral of 1 dx, which is simply x. So you remember that integration by parts is integral of u dv is the same as uv minus integral of v du. So which means integral of ln of x dx, uv, this is the u, this is our v, so it will be x ln of x minus integral of v, which is x, times the u. The u is 1 over x, and then the x. And this simplifies to, you see this will be 1, this will be 1, so we'll have x ln of x minus integral of just dx, or 1 dx. And integrating 1, we get x, so it'll be x ln of x, then minus x plus constant of integration. So this is the value of the integral of ln of x. So that is the solution to the first problem. And then problem 2 is to integrate sine inverse of x. Integral of sine inverse of x dx. We do the same trick. We say this can be written as integral of sine inverse of x times 1 dx. And we use integration by parts. Integration by parts to find the solution. So we do this by saying let u to be sine inverse of x and let dv to be 1 dx. So this means that v would be the integral of 1 dx, which is just x. And then this one, we can use, let's change this one as x sine of u is the same as x. So u equals to sine inverse of x, the same as saying sine u equals to x. And then apply d dx on both sides. So we'll have d dx of sine of u is equals to d dx of x, which is the same thing as saying when you differentiate sine, you get cosine, but then u is assumed to be a differentiable function of x, so you attach du dx, and when you differentiate x with respect to x, you get 1. So from this one here, if we are saying that u is sine x, so this is the same as x over 1. So sine is opposite over hypotenuse, so opposite is x, hypotenuse is 1, and this will be the square root of 1 minus x squared, Pythagoras theorem. So, which means if you define cosine of u in this triangle, cos is the same as adjacent of hypotenuse, so it'll be simply square root of 1 minus x squared. So we have square root of 1 minus x squared du, then you multiply through by dx, so we get dx. So which means dx alone will be given by this. So du will be 1 over square root of 1 minus x squared dx. Now the integral of sine inverse of x dx is uv. So u we have said to be sine inverse of x, v we have gotten to be x, so it will be x sine inverse of x minus v du, so integral v, which is x, and then du is square root of 1 minus x squared, and then dx. And this other part, we use substitution method. So to integrate x over square root of 1 minus x squared dx, just let u to be 1 minus x squared. So which means du is minus 2x dx, which means dx is minus du over 2x. So this will be the integral of x over square root of u times minus du over 2x. So x and x cancels out. X and x cancels out. And then you can factor out a half. So you have a half integral. Now du, let's factor out negative a half because there's a negative sign here. So du over square root of u. So which is the same thing as saying negative a half integral of u raised power minus a half, and then du. So using power rule, we'll have negative a half times u raised power minus a half plus 1 over minus a half plus 1, and then plus c. So minus a half plus 1 is a half. So reciprocal of a half is 2. 2 times minus a half is minus. So this is just the same as minus u raised power a half, and then plus c. But remember, u is 1 minus x squared. So therefore, integral of sine inverse of x dx will be, here we have x sine inverse of x. Now this minus and this minus will be plus, so plus, but u is 1 minus x squared raised to a half, and then plus c. So which is the same thing as saying integral of sine inverse of x dx is equals to x sine inverse of x, and then plus raised to a half is just the square root of 1 minus x squared, and then you add a constant of integration c. So therefore, that will be the solution to that particular problem.